the Jeffreys grain size is coming out. So, what I will now do is I was just interested in calculating the another derived quantity called number density. So, the number density, if you recall the lecture, we can try to do that exercise for that graphite nodular microstructure, which is quite interesting because the nodular shape is almost close to the spherical or sphere. And if you recall, for the sphere, the expression what Professor Sandeep has demonstrated or derived is NV is equal to 1 by beta times Na to the power 3 by 2 by Pp to the power half, square root of Pp or whatever. So, where the beta has a number, it is 6 divided by pi to the power half. So, we can just try that exercise just for a curiosity, I would like to try. So, there again because you can use that same probe as the earlier one, and you can count those area. Since we have already done the exercise on Na to calculate this space filling grains, and it is of a similar nature. So, what I will do is I will just do a demonstration, or again I do not want to we can do a demonstration, it is not a problem. So, I will just take up the microstructure again and then do this calculation. You can keep this graphite nodular microstructure like this, and then the probe can be kept like this, and you can just keep this and then start counting. So, the rule is you have to exclude this particles which is intersecting these lines and include the particles which is intersected by this line. So, just I count for the so you can just start counting like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. So, it is 37. So, one can do up to n. In this case, I think I have done up to 35, n up to 35. So, you can count this and then put it in the Excel sheet as you like. So, again since we know this dimensions already, we do not have to, it is easy for us to calculate this again. Yeah. Okay. So, let us now start writing this numerical density under the assumption of constant size and shape. So, we write this expression NV, which is equal to number per volume, and NV is written as 1 by beta times Na to the power 3 by 2 by Pp to the power half. For spheres, beta is 6 upon pi to the power half. Okay. So, which is, you can just do this calculation, 1 by 1.382 into 79.05 divided by 0.1389 to the power half, this is 3 by 2. So, you will get approximately about 1365 grains or particles per mm cube. See, here I have used, if you choose to follow the micrometer scale here, this number will be too small, because it will be a micrometer cube. So, the number of particles, if you can imagine, in the micrometer cube volume will be too less. So, in order to have that feel, so I converted that micrometer into mm. So, now you have mm cube, you have a larger volume, and then you get some reasonable number like something like this. So, you know that pp and Na already. So, for this we have calculated. So, I have taken that and then just put them into the Excel sheet. So, if you can see that this is what I have done in this column. You can see that the particle counts Na and then finally Nv. So, I get around average number of particles is about 1435 and the standard deviation is about 376. So, you can just report it like this: 1435.5 minus 1.96 into 376.7 divided by 35, 1435.5 plus 1.96 into 376.7 square root of 35. So, which is, so Nv at 95% confidence is, you can write Nv is equal to 1310 to 1560 particles per millimeter cube. So, this is how you can just visualize. Just to give you an exercise, which you have the parameters Na and Pp. So, it is a good exercise to try, and all that you have to be careful is about the converting this scale and then looking at the micro marker. Normally people commit mistakes in this, even it is several times. If you try some small error here and there, you will miss because of the not considering the right scale and so on. But nevertheless, if you taken care of this, and this kind of exercise is very good to understand the derivation of the 3D quantities by the stereological parameters. So, I hope this exercise was useful, and then you can try similar exercise on some of the new microstructures again. So, with this I close this tutorial. Thank you.